Colts, welcome to Readiness Assessment 4, Part 2, numbers 9 through 18. So question number 9, it says, what is the slope of a line that passes through points 0, 7 and negative 3, 0? So this is a review from a readiness assessment we've already done. But just to go through, we're going to label x1, y1, we're going to label x2, y2. We're going to plug it into our formula, m equals y2 minus y1 over x2 minus x1. We are going to use parentheses to keep us from making mistakes, and we're going to substitute. So our y2 is 0, our y1 is 7, our x2 is negative 3, and our x1 is 0. So 0 minus 7 gives us negative 7 on top. Negative 3 minus 0 gives us negative 3. So we end up with a negative over a negative, which gives us a positive 7/3. So we end up with B. Going to number 10. What is the y-intercept of the graph of the equation 5x plus a negative 2y equals 8? I think they do the plus the negative 2y maybe to give you just a different form, to show you how to do it, or maybe just to throw you off a little bit. But we want to know the y-intercept, so we want to put it in y equals mx plus b format. So I'm going to use a sticky note, so we got some space for this one, just to show some work. So we'll say 5x minus 2y equals 8. So that's going to be the same as plus a negative 2y. To get the y by itself, I'm going to subtract 5x from both sides. Do not lose the negative in front of your 2 or you'll get it incorrect. And then I'm going to write negative 5x plus 8. And then I'm going to divide by negative 2 to get the y by itself. So I'm going to use my butterfly method. And I'm going to end up with a negative 5 over a negative 2x plus an 8 over a negative 2. So I have a negative over a negative, gives me a positive 5 halves x, and then plus an 8 over a negative 2, which gives me a negative 4. And in this case, they're just asking us for the y-intercept, which is just going to be our value of b. So in this case, it's going to be negative 4. Make sure you guys show your work or staple the paper to it. For number 11, we want to find which ordered pairs are solutions. That's saying which one of these are on that line. So it says to select all that apply. So again, we're going to use a sticky note. You could go through and you could graph it, which might be an easy way to do it if you see it. But if you don't have nice graph paper, it's also good for us to be able to do it algebraically. So to show us how to do it algebraically, I'm going to write my first coordinate, which is negative 2 comma negative 7. This is going to be my x. This is going to be my y. So my equation is 3x minus y equals 1. I'm just going to put it up here at the top because I'm going to use it numerous times. So first time I'm going to do 3 parentheses. My value of x is negative 2 minus, using parentheses to help us not to make an error. So if you're not sure where I'm getting these from, this x value matches with this x here. And this y value goes with our y value here. So I'm substituting them in. So I have 3 times a negative 2 gives me negative 6. And a negative times a negative gives me a positive 7 equals 1. Negative 6 plus 7 is a fancy way for saying 7 minus 6, which is 1. 1 equals 1, so this one works. But be careful in this one, it says select all that apply. So remember, there's a possibility that there's more than one. So we're going to try the point negative 1 comma negative 4 now. So negative 1, negative 4. This is my x, this is my y, so I'm going to do 3 times negative 1 minus a negative 4. That looks kind of like a 9, so let me rewrite it for you. 3 times negative 1 gives me negative 3, and negative times a negative again gives me a positive, equals 1. Negative 3 plus 4 gives me 1. 1 equals 1. It works. So I'm going to say B also works. So then I go to C. I'm going to do the point 0, comma 1. So I'm going to say 3 parentheses 0 minus 1 equals 1. 3 times 0 gives me 0 minus 1. Negative 1 does not equal 1. So make sure you don't drop that sign and say, well, it's really close. So in this case, this one does not work. And then the last one we're going to try is 3 comma 8. Now don't lose steam and just say, well, I got 2. That's fine. Try them all. So I'm going to do 3 times 3 minus 8 equals 1. So I end up with 9 minus 8 equals 1. 1 equals 1. So this one also works. So I end up with 3 options in this case. that works. Okay, number 12, rewrite the equation in terms of y. So that means we're just going to get the y by itself. So I'm going to use a blank one again to help us. We got some space to work with. So we're going to say 6x minus 9y equals 12. I'm going to get the y by itself, so I'm going to subtract 6x on both sides. Negative 9y equals negative 6x plus 12. Divide by negative 9 to get the y by itself. And again, we're going to use our butterfly method. Oh, don't forget the negative. So I'm going to have negative 6 over negative 9x plus 12 over a negative 9. So I have a negative over a negative for my slope. It gives me a positive, so I have 6 over 9x minus 12 over 9. Now we need to reduce, because 6 and 9, 3 goes into both of them. So I'm going to reduce that to 2/3 x. And then 12 and 9, 3 also goes into that. It's going to be negative. And I'm going to say 3 goes into 12 4 times and goes into 9 3 times. So we end up with our final solution for this being y equals 2/3 x minus 4/3. Okay, going to number 13, name the property of addition modeled here. If you're not super familiar with these, which, I mean, you guys probably don't sit around and read about these, it'd be a good idea to Google them if you have access to a computer, and then look at an image. If you look at an image, it'll give you an example. But in this case, because we had A and then we had B, and we added the same thing on both sides, we're going to use this thing called the addition property of equality. What I do to one side, I have to do to the other side. Okay. Moving on to number 14. Which of the following equations are equivalent? So remember, this is our point slope form, and we're trying to put them in y equals mx plus b format. So this is select all that applies, so make sure we look through and we see if there's more than one solution. So I want to get it into y equals mx plus b format. It's pretty close, but we got to be okay with working with fractions. So before I move that negative 4, I'm going to take this 2/3, and I'm going to distribute it to get rid of those parentheses. So I'm going to have y minus 4 equals 2/3 x, and then 2/3 times negative 1 is going to give me a negative 2/3. So I'm going to add 4 to both sides. So I end up with y equals 2/3 x. Well, if we look through, all of them have 2/3, so that's not going to help us. Then I'm going to have negative 2/3 plus 4. So to give us some space to work right here, we're going to add those. So I'm going to put the 4 over 1, and then I'm going to get a common denominator. So I'm going to multiply this by 3, and I'm going to multiply this by 3. Let me erase that little dot so it doesn't get confusing. So I'm going to end up with negative 2/3 plus 12 over 3. Because I have a common denominator now, I can do negative 2 plus 12, which gives me 10 over 3. And we see that it's positive. So right now we know that we can get rid of A, and everything else is positive. And we say, okay, well, 3 goes into 10. It doesn't go in evenly, so we know it's not going to be C because that gives us a whole number. So we see for sure, we know it's D. But it says select all that applies. So remember when we write it as mixed numbers, 10/3 can also be written as 3 and 1/3. So we're also going to select B in this case. Okay, moving on to number 15. These ones might look a little scary because we get some fractions we're going to be solving. Now there's a couple ways to do this. You can take your multiple choice options and you can plug them in and see if they work. Okay, but what if it's no solution? And I guess we pick that one last. So that might be just as much work than if we just solved it. So we're going to go through and we'll solve it together. So we're going to have 3 parentheses 1/6 x plus 9 equals 1/2 x minus 27. Now before I start going through and trying to get rid of fractions, I'm going to distribute that 3 first so that I can, and then I'll just see if there's one fraction or something that works for both of them. Now I could divide by 3, but then if I divided by 3, then I would have 1/2 divided by 3, which would make it a little bit more complicated for us to do. So we're just going to distribute. And we got to be okay with distributing. So 3, this is technically like 3 over 1. And we're going to multiply it times both. So 3 over 1 times 1 over 6 is going to give us 3 over 6. Still have an x. 3 times 9 is going to give us 27. And then we're going to end up with 1/2 x minus 27. So if we look at them, we're like, oh, they're almost the same. Well, I can reduce this 3 over 6 to 1 over 2x plus 27 equals 1 over 2x minus 27. So if you still don't see it and you're not sure, okay, don't go through and just say, well, I think it's B. It must be that one. If you want to, combine your x's. So I'm going to subtract 1x, but we see that they're not exactly the same on both sides. I have a positive 27 here, and I have a negative 27 there on the right side. Do not discredit that negative and just erase it. So because they are not equivalent and they are not the same thing, we are going to end up with no solution for this case. All right, moving on to number 16. So again, we have another one with a fraction, and we're going to solve. So you can go through and you can plug some in, but you got to be comfortable with plugging in 2/5 and 5/2 in case that's one of the solutions. So I'm going to show you the algebra of how we solve it though. 3x plus 1/2. I'm just going to rewrite it. Okay. Now before I do anything with that fraction, I can move this 3x. He doesn't need to be over there. I'm going to join him with the other x's on this side. And I'm going to end up with 1/2 2x plus 6 equals 3x plus 1. Now you can go through and multiply by the reciprocal, but because this is a half and my number 2 inside my parentheses and my number 6 are both even, we could chop them in half. It should be pretty easy. So half of 2 is going to be 1, and in this case 1x. Then I say half of 6. Well, half of 6 is going to give us 3. So then I end up with x plus 3 equals 3x plus 1. I'm going to subtract x on both sides, and I get 3 is equal to 2x plus 1. I'm going to minus 1. I end up with 2 equals 2x, so I divide by 2, and x equals 1. So in this case, we end up with option B. All right, 2 more. Here we go. Number 17. This is when we're going to deal with inequality. So we got to solve that inequality. It's just a fancy way for saying get the x by itself. But instead of having an equal sign, we're going to have an inequality sign. So we need to remember our things about multiplying or dividing by negatives. So in this case, we could go through and distribute the 1/3, but it's not going to make our life any easier. So let's get rid of the 1/3. So actually, let's rewrite it over here. I want to get rid of that 1/3. So I'm going to multiply by its reciprocal, which is going to be 3 over 1. And what I do to one side, I have to do the other side. So I multiplied by a number, but it was not negative. So right now it doesn't do anything to my inequality. So I end up with x minus 6. And 3 over 1 is just a fancy way for saying 3. So I'm going to say 2 times 3 is going to give me 6. Then I'm going to add 6 to both sides. And so once again, I did not multiply or divide by a negative. And so I end up with x greater than 12. So we'll put it up here. And then the last one. Number 18 is a little bit different. It has an inequality, and then it says which values apply, and all of our solutions have equals. So we got to figure out which ones will fall in to that inequality. So for instance, for number 17, a number greater than 12 would be 13, or 12.5, or 12.1, right? Or 20. So we don't want anything less. So we got to figure out what this inequality is, and then see which one of these work. And because it says select all that apply, there's going to be possibly more than one. So rewriting it, we're going to get the x's by itself. I'm going to subtract x. I'm going to say 7 plus 3x greater than negative 2. I'm going to subtract 7. So I'm going to say 3x greater than negative 9. So again, I have not multiplied or divided by a negative. I'm going to divide by 3, which is a positive number, so still it doesn't switch it. And I end up with x, my inequality sign, negative, and then negative 3. So you have to know if that's greater than or less than, or else it's going to be hard for you to get it. So I know it's not equal to negative 3, so it's not going to be this one. And that says, in our case, I want x greater than negative 3. Negative 6 is not greater than negative 3, but 0 sure is, and 3 is. So in this case, we would get B and C. And that concludes Readiness Assessment number 4. Hope it helps.